Section 5.5, Day 2, this is going to continue with some of the more advanced factoring methods. So here we have the polynomial 8t to the 6th minus 38t to the 4th minus 10t squared. As always, we want to start off by looking to see, is there a GCF? 8, 38, and 10 have a number in common. It's a 2. They also all have at least 2 t's. Our GCF is 2t squared. Divide everything by that 2t squared to find out what's left over on the inside of the parentheses. All right, so now we have this, and we want to make sure it's factored completely. So we want to try to factor what's inside the parentheses here. Now that almost looks like an earmuff problem, but the issue is that our exponents are too large. We can earmuff when we have something like t squared minus 19t minus 5. Okay, when we have t to the 4th, t squared, we can't do it. So what we're going to do is we're going to have a second variable that we're going to use as a stand-in for the t's. Here's what I mean. So let's say we picked y, and we say let y equal t squared. Okay, so basically this right here we can replace with a y because y equals t squared. All right, so if y equals t squared, what does y squared equal? Well, y squared would equal t squared squared. And since we're just going to multiply those exponents, y squared equals t to the 4th. We have a t to the 4th right here, which means we can replace that with what it's equal to, y squared. All right, what's the point of all this? Is now we can write it like this: 4y squared minus 19y minus 5. This is earmuffable. Okay, we have blank times blank equals negative 20. Blank plus blank equals negative 19. Our two numbers are negative 20 and positive 1. Remember that since there is a coefficient here, we have to do those two fractions. 4y over negative 20, 4y over 1. We look to see, can we simplify either of these fractions? We can for the first one. That's going to become y over negative 5. Okay, so at this point, we could rewrite this factored as y minus 5, 4y plus 1. All right, and as a last step, we want to take what y equaled, and we want to put it back in for the y's. Because we started out with t's, we want to finish with t's. So we want to put those t squareds back in for the y. And let's not forget our GCF, which stays out front there. So our solution would be 2t squared times t squared minus 5 times 4t squared plus 1. Let's do another one. 16g to the 4th minus 625. This one's equal to 0, which means we have to solve it along with factoring it. This is almost a difference of square problems where we can square root them, but the issue is that our square roots are too large. So let's first, if we look for a GCF, we'll see that there isn't one. Okay, we're stuck with the problem as it is here. So we're going to let y represent a g squared again. Okay, now that's not actually replacing anything up here because there are no g squareds. But if y equals g squared, then y squared is g squared squared. Okay, multiply those exponents. Y squared equals g to the 4th. Okay, which means this right here we can replace with a y squared. All right, so this would look like that. 16y squared minus 625. This is now a difference of square problems. We have two things separated by a minus sign. They both happen to be perfect squares. The square root of 16y squared is a 4y, and the square root of 625 is 25. So we would have two parentheses. One gets a plus, one gets a minus. Now we have y's here, but we don't want y's because we started with g's and we want to end with g's. So at this point, we put these g squareds back in for those y's. 4g squared minus 25, 4g squared plus 25. We're not finished yet. Okay, there's actually two steps. Most notably, this has an equal sign. We're going to have to solve it. But before we can solve it, we can actually factor it even further. So if we look at this first one, we have another difference of squares. Okay, so we have 4g squared, which we can square root and get 2g. And we have a 25, which we can square root and get 5. Okay, so that we can split up to two parentheses. 2g plus 5, 2g minus 5. This one we can't do it because there's a plus sign. And now as a last step, we have to take each of these parentheses and we set them equal to 0. So we would do 2g plus 5 equals 0. Okay, 2g minus 5 equals 0. 4g squared plus 25 equals 0. And we would solve all of those. Okay, and we get our answers. Now, for the solutions, there's always going to be this many solutions. Okay, so if it's g to the 4th power, we're going to have 4 solutions. It might be the same solution over and over and over again. So, for example, it could be just 1 as the same root 4 times. But in most cases, you'll have 4 different answers. So here's the first, here's the second, and then there's 2 here, 3, 4. This we went over in yesterday's notes, but it's a complicated topic. So we're going to do 2 more examples of sum and difference of cubes. 16b to the 5th plus 686b squared. Is there a GCF? Well, they're both even, so we can take out a 2. And they have at least 2 b's each. So let's take out a 2b squared, divide both of these by a 2b squared, and we get 8b cubed plus 343. Now, when we look at this, we want to use one of the many factoring methods that we know. Okay, it's 2 things. If there was a minus sign, we could try to square root it and see if difference of squares worked, but it doesn't because first of all, we can't square root these numbers, and second of all, we would need a squared and not a cubed. Okay, so instead, this is going to be a sum of cubes problem. Sum because there's a plus there. So we want to figure out what are the 2 things that are being cubed. So obviously, we have a b being cubed, but what is cubed which turns into an 8? And the answer is a 2. So 2 cubed equals 8. It's one of those things that you'll need to know. Okay, this is another one that eventually you'll come to recognize once we do a bunch of these problems. 343 is also a perfect cube. It's 7 cubed. So let's rewrite this like that. And we mentioned it's the sum of cubes, which we're going to plug into this equation here. And now we're just putting a 2b everywhere we see an a, and we're putting a 7 everywhere we see a b. So it will look like this. And then as a last step, we want to just simplify everything that we can. When we simplify, make sure you square everything here. So it's 4b squared, multiply these, square the 7, and we get our answer. So the GCF, don't forget, it's always out front. 2b plus 7, and then we have 4b squared minus 14b plus 49. All right, last one, and when you do these, please make sure that you show all the steps. Don't be lazy and try to skip steps because that's when you're going to end up getting things wrong. A to the 8th power plus a squared b to the 6th. GCF, they both have a's. The smallest number of a's that they both have is 2. So a squared is going to come out as a GCF. We divide both of these by a squared. Here they would cancel. Here we subtract them. So a to the 6th plus b to the 6th. All right, so this again is going to be sum of cubes. And the tricky thing here is figuring out what cubed equals a to the 6th. Now, keep in mind that when we cube something, it's times itself 3 times. A squared times itself 3 times. We would add these exponents. So a squared cubed is a to the 6th. Same thing with b squared cubed. We're going to plug it into this equation. Anywhere we see an a, we're going to plug in an a squared. And anytime we see a b, we're going to plug in a b squared. Okay, make sure you don't forget your GCF. All right, so we have a squared plus b squared, a squared squared minus a squared times b squared plus b squared squared. Simplify it as much as you can. Here we can make that a to the 4th. Here we can make that b to the 4th. In the middle, it just loses the parentheses around them and becomes a squared b squared. And that's our answer.